Okay, part 3 of week 3 written assignment, video support. Piecewise defined functions. It's a mouthful, but all it means is some functions, instead of using one formula, need to use multiple formulas or descriptions in order to get the whole picture. So a piecewise defined function is typically kind of like a Frankenstein's monster, where it's a function that's made by stitching together several other functions or several function formulas. Here's an example very similar to the one you work on in the worksheet. F of x equals, but instead of giving a single formula, we say f of x is x squared sometimes, it's 1 sometimes, and it's x some other times. And this information over here tells you when to use those various formulas. Basically, you start by looking at the way the domain is broken up. When x is less than or equal to 1, then we're going to just treat this function like just this part here, f of x equals x squared. We're going to input x's in this range, and we're going to get the square out for the output, okay? This part of the domain. When x is between 1 and 5, the outputs are just going to be 1. F of x equals the constant function 1. And when they're greater or equal 5, when we're inputting something that's 5 or more, then we're going to pay attention to this formula, x. Now, in your example, you have a table so you can point plot and get a bunch of points on your graph. And I want to do this a little fast, so I'm going to jump ahead and say, if I just graph f of x equals x squared and I didn't pay attention to any of the rest of this stuff, I would get a parabola, and it would go through these points here. Let's see, it would look kind of like this. Sort of like that. That's just, I'll write it as an equation, y equals x squared, right? And if I just did f of x equals 1, and that was the only thing I was graphing, I just point plot, no matter what my input was, my output would be 1. The second coordinate's 1, 1, 1, 1, 1, 1, 1, 1, 1. That would look like this. That's y equals x, just that, I'm sorry, y equals 1. Just that horizontal line. And if I just had the function f of x equals x, that's another one of our basic elementary functions that you point plotted earlier in the activity, in the assignment. You'd get this straight line that goes to the origin with a slope of 1, right, that looks sort of like that. Actually, if I draw that a little better, I think all of these have an intersection at the point 1, 1, so I'll draw that like that. So basically, that's y equals x. Basically, I've got 3 function formulas, and the functions individually would graph like this, but I have to pay attention to where in the domain each one of them is specified. So let me also kind of look at breaking this down by how these instructions break down the domain. For x less than or equal to 1, I'm talking about everything over here is where x is equal to 1 or smaller. For 1 less than x less than 5, 2, 3, 4, 5, I'm talking about a vertical strip here where x's are between 1 and 5. And for x greater than or equal to 5, I'm talking about zone 3, right? So I'm kind of going zone number 1, zone number 2, zone number 3, that's where these various formulas apply. So the way my piecewise defined function is going to look is when I'm over here where x's are less than or equal to 1, I'm going to pay attention to this first formula, x squared, and I'm going to get this parabola. It's going to be a graph like this, it's going to come along like this, right up until x is equal to 1. And even where it's equal to 1, if I do 1 squared, I get an output of 1. I'm going to get this piece of graph. Just a chunk of a parabola that stops right there. Okay? Then, when x is strictly between 1 and 5, I'm going to pay attention to the formula 1. So, I'm going to pay attention to this constant graph. Right, I'm going to get a piece of this flat line, just between 1 and 5 for x's. What happens at 5? This is supposed to be 1 for any x less than 5, strictly between 1 and 5, but not equal to 5. So I want to include this line all the way up to 4.5, 4.9, 4.99, 4.99999, but not 5. So I'm going to put an open circle there to kind of show, here's something that commonly happens in piecewise defined functions. The parabola is just stitched right to the line. So there's no break here. Okay, and then when I get to 5, I'm going to leave an open circle to say I don't actually include that point, because when x equals 5, I'm starting to pay attention to this formula. And let's see, I want to start up here on this vertical line. So actually, 5 comma 5 is a point on this graph. And then I want to continue with the rest of this line for the rest of x's out to infinity. So now let me erase the parts of these graphs that I wasn't including in my piecewise defined function. And I'm going to get an overall graph that looks sort of like this. Okay, similar to the example that you do in the exercise. So point plot first, I skip that part for speed, and then pay attention to where you are in the domain and what happens at the boundaries between the parts. And you'll get something like this, sort of a 3-part stitch together. And you'll also see some of this in the MyMathLab homework. Okay, last but not least, let's go back to the activity page. There's where the piecewise defined function is going to be. And let me go to the next page where you're going to enter a kind of an icky function into your calculator, and then you're going to use the second calc menu in order to develop some information for this. So this is kind of reviewing the calculator stuff where you're going to get a graph. Let's see, this is a 4th degree equation. You know, you're going to get a graph that maybe, where'd my pen go? You're going to get a graph that might look like, absolutely wild guess, might look like that. On some appropriate window, you'll show the minimum and maximum x value, minimum and maximum y value. And then you're going to use second calc menu to find these max and min points with left and right bounds and hit enter to locate those points. And I would label them on the graph. And this is going to allow you to answer all of these questions down here. What's the range of t of x? On what intervals is it increasing? See how having these max min points will allow you to say where it's increasing or decreasing. Does it appear to be even, odd, or neither by symmetry? And how many solutions does this equation have? Of course, this is a question about how many zeros or x-intercepts your graph will have. And then you'll go on to the last part. There's still 5 pages left in the handout, but only 1 page that you have to fill out. The rest of this part 5 is about review skills from Math 95, and you're going to do what is kind of a form of something I usually use as an in-class quiz. You guys are lucky you get to do it as a take-home, but factor completely a couple of these, simplify roots. I know that's been a little bit of a bugaboo, and this includes simplifying a cube root, a third root, and solve a couple of equations. And then what follows here is a review handout that you can use to help you. You should be able to do this without a calculator, but if you're finding that you're rusty or you're not sure of your answers, read this handout here about some of these facts and formulas that you should have in your memory for Math 95, general approach to solving polynomial equations, examples for simplifying roots, for instance, so worked out with steps, and more examples on solving equations. And finally, the last page is solutions to all of those review skills. These example problems back here in the review skills document, you do not have to complete and turn in, although you may want to work some of them in order to check solutions. I'll look for you to fill out this, this part, this first page, this take-home quiz. And I think you should probably be able to be very accurate with this because you've got the support document to check out examples. And these will be types of skills that we apply in Math 111, which is why I'm reviewing them now. Okay, thanks a lot, guys. And I'll look forward to receiving all of this great work from you by next Thursday.